Good evening, my YouTube viewers. It's Crystal here, and what I wanted to do in this video is also talking about Kaggle's Season 5, Episode 8 competition. But basically, what has happened is I have had to put a few things on hold or slow a few things down. And since I was slowing those few things down, I had time to work on this Kaggle competition. And I had time to see if I could improve my score. And so basically what happened yesterday in the Kaggle competition is I made a mistake when I was preparing the submission. And because I made a mistake when I was preparing the submission, I was looking at other people's code to see if I could find out what the problem was. Well, I eventually found out what the problem was, but not before I had made several Jupyter notebooks. And this particular Jupyter notebook that I made it using TensorFlow, and I did actually use some of the actual code for the neural network. I actually borrowed that code from somebody else, but the rest of the code was mine. The neural network code I borrowed, but the rest of the code was mine. And since I spent so much time working on this competition question, and like I use logistic regression, which I haven't made a video on that yet, but I scored a 92% on that. And I did Hist gradient booster classifier, which I scored the highest on that. And I used extra trees, and I scored pretty good on that. And now I wanted to do the video on TensorFlow because I scored high on TensorFlow, not as high as I did on Hist gradient boosting classifier, but I did score high on it. And because I scored high on it, I decided that I would go ahead and review the code for it, just to show you how to do the code in a neural network in TensorFlow. So without belaboring the point, I'm going to go ahead and do the code review so you can see the code that I use. And as I said, the code is mine. The code is the code that I made up, except for the code for the neural network, and I borrowed that code from somebody. So the first thing that we're going to do is we're going to define the problem statement, and it's use banking data to make probability predictions. So basically what you're going to be doing is you're going to be predicting on a probability. And with this particular Kaggle competition question, they don't really give you a lot of information about the data set. It would be better if they had told you what each column of data was for. But I personally didn't see that. I had a quick look at the competition question, and I personally didn't see that. So if what the column data was for is in the competition question, it certainly wasn't readily available that you could quickly see. So I'm not sure exactly what we were predicting on because the target just said Y. So after we have defined our problem statement, then what we want to do is we want to import our libraries that we're going to need to use to execute the program. So we're going to import NumPy as NP, which is a numeric library, and it also creates NumPy arrays. We're going to import Pandas PD, which is a data processing library, which also creates data frames and series. We're going to import OS, which goes into the operating system of the computer or the network. From scipy.stats, we're going to import ks_2samp. So what this is, scipy is Python's scientific library, and stats is a statistical module within scipy, and ks2samp is the Kolmogorov Smirnoff test with 2 samples, and it's a non-parametric test. And we're going to use that to check to see if any of the columns of data from the trained set and the test set are not from the same distribution. And if they're not from the same distribution, then what we will do is we will drop those columns because it will affect the prediction if they're not from the same distribution. Then we're going to import sklearn, which gives us machine learning functionality. And then after we've imported sklearn, we're going to import TensorFlow, which is what we're going to create our neural network with. And then we're going to import matplotlib.pyplot.splt, which is a visualization library, and we're going to import Seaborn as SNS, which is also a visualization library with a statistical element to it. And then we're going to import warnings. And then you see after we have imported our libraries, we got a warning, and that is because of TensorFlow. And now what we're going to do is we're going to use the OS library to retrieve the files. And the files that we're going to retrieve are going to be CS files, being train.csv, test.csv, and sample submission.csv. And after we have retrieved the files, then what we're going to do is we're going to read the files and convert them to data frames. And the 3 data frames that we are going to create are going to be train, test, and submission. And then we're going to set the Jupyter Notebook up so we can see all of the columns. So we type in pd.set_option brackets display.maxcolumns, none. And what that does is that will allow you to see all of the columns in the data frame. So now you see that we created the train data frame, and you can see that this is the train data frame. And as you can see, the target just says Y. So it doesn't give you a lot to work on. You know that you're predicting something, but you're not sure exactly what it is that you are predicting. And then we check info on the train data frame, and you can see that the columns are either integer or object. And an object gives you categorical values. So what we want to do is on all of the columns of data that are of D-type object, what we want to do is we want to find out the unique values. So we printed off the unique values for every column of data that is of D-type object. We checked for any null values, and there are no null values in train, so that's good. So we didn't have anything to impute. And then so now what we've got is we've got our test data frame. The test data frame is of the same format as the train data frame, except for it doesn't have a Y column because that's what we're going to be predicting on. We check for any null values in the test data frame, and we don't have any null values. So we wanted to check all the unique values, unique categorical values, and all of the columns that were of D-type object. So we've got the unique categorical values of all the columns that are of D-type object. So the submission this is the format that Kaggle wants us to submit our work. You want the first column is your ID, and your second column is Y. I'm not sure exactly what Y is. Y is your target, but I'm not sure exactly what they mean when they say Y because they didn't elaborate on it on the documentation for the data sets. Now what we're going to do is we're going to perform the Kolmogorov-Smirnov test. And what that does is that checks to see if any of the columns of data between the train data frame and the test data frame are not in the same distribution. And because it gives you a PV or p-value, And if the p-value is less than 0.05, that means that the columns are not of the same distribution. So the only column of data that we had that was not of the same distribution was ID. So we're going to go ahead and drop that column, but we would have dropped it anyway. And the reason why we would have dropped it anyway is because Pandas automatically indexes every row of data. So you don't need an index row. You don't need an ID row. And then so we drop the ID, and you can see that the shape is one less column of data in both the trained data frame and the test data frame. So now what we're going to do is we're going to analyze the target. And when we analyze the target, you can see that there's a very big imbalance, class imbalance. So that class imbalance is going to have to be corrected. And then so what we do is we analyze the age, and you can see that when we analyze the age, you can see that it doesn't look like a normal data set. And the reason why it doesn't look like a normal distribution is because it's skewed to the right. So you have a lot of people between 30 and 40, and then from 40 all the way down to 80, maybe even 85, it decreases. And then between 70 to 85, you've got outliers. And then we're going to analyze the job. When you analyze the job, you can see that the most common job is a technician, and the second most common job is a blue-collar job, and the least common job is unemployed. So now what we're going to do is we're going to analyze the marital status. And so married is 64.1%, single is 26%, and divorce is 9.9%. And now we're going to analyze the education. So secondary is 53.6%, primary is 30.3%, tertiary is 13.3%, and unknown is 2.8%. Now we're going to analyze default. I'm assuming that this is default on a loan, but as I said, they don't give you very much information about the data set, but I think that's what it's about. And you can see that the vast majority of the people did not default, but a very small minority did default. So that's going to give you a class imbalance. So now we're going to analyze housing. You're saying more people don't have housing than do have housing, and there is a class imbalance, but it's not a large class imbalance. So now we're going to analyze loan, and then I'm assuming that this is, have they taken out a loan? And so again, you've got a class imbalance. You have a lot more people who haven't got a loan than do have a loan, but it is a large class imbalance, and a very small proportion of the people do have a loan. Analyze contact. This is how you get in touch with the person. So 64.9% you can get in touch with them through their mobile phone, 30.9% is unknown, and 4.2% is the telephone. And then you're going to analyze the day, and I went ahead and made it a histogram with 31, a bin of 31. And so that way you could have like one day of every month if that's what you wanted. And you can see the most frequently occurring day is 20. So we're going to analyze the month. You can see that the most commonly occurring month is August, and the least commonly occurring month is December. So we're going to analyze the P outcome. So 89.7% is unknown, 6% is other, 2.4% is failure, and 2% is success. Now we're going to create a heat map using Seaborn, and we're going to create a heat map on only the numeric features. And so this is the heat map that's been created on the numeric features. And as can be seen from the heat map, they're not very highly correlated. If they had been really highly correlated, we could have deleted, dropped a column or two of the really highly correlated columns or features, but since they're not highly correlated, we just left it. Now we're going to use sklearn's ordinal encoder to encode all of the columns that are of D-type object. And then so on the train column, we're going to use fit transform, and on the test column, we're going to use test, because the test column is going to be encoded based upon the train column. So now we check train info, and you can see that we no longer have any object columns. They're all either floats or integers. And the same thing like with the test file. If the test data frame, there's no more D-type object. It's either floats or integers, so it's numeric. So now what we're going to do is we're going to define the dependent and independent variables. So y equals train dot pop y. So that means you pop y out of the train data frame. So y is no longer in the train data frame. And then x is now the train data frame, and x test is the text data frame. So we're going to scale the data using standard scalar, but truthfully, we scaled it using the standard scalar, but truthfully, I don't really think that it was necessary, because I thought about it, and I thought, well, maybe we should use the standard scalar with his gradient boosting regressor, and maybe we should use it with extra trees, and maybe we should use it with logistic regression. But with the y variable, you either have a 1 or a 0, and since you either have a 1 or a 0, all of the values are closely dimensioned, and even if you use the standard scalar, then it's still going to be either a 1 or a 0, even if you use the standard scalar. So I don't know if the score would be better if we didn't scale it. I could go through and try to do it without scaling it and see if that improved the score, but it's up to you if you want to scale it, because on the y, it's either a 1 or a 0, so that's what you're going to get when you scale it. It's either going to be a 1 or a 0. And now what we do is we set up our class weights. The reason why we set up our class weights is because there is a class imbalance. And because there is a class imbalance, you have to set the class weight up. And you can see that when we set up our class weights, 0 is 0.5686 and 1 is 4.1441. Those are your class weights. So now you're going to define your model, and this is going to be with TensorFlow, Keras TensorFlow. So model is a sequential model, and then dense brackets 256, comma, activation equals ReLU, comma, input dim equals x dot shape 1, batch normalization, and dropout is 0.3. And then the following one is dense brackets 128, comma, activation equals ReLU. You've got batch normalization, and then you have dropout 0.2. And the next one is dense bracket 64, and activation equals ReLU. You've got batch normalization, and dropout equals 0.2. So what we've done, and then the last one is dense brackets 1, because you've got one output, brackets activation equals sigmoid. And then so what we've done is we created a neural network with several layers, and then the layers will become increasingly smaller until you get down to 1, because with a logistic regression, you're only going to have one output. And now we're going to compile it. So the optimizer is going to be Atom, the loss is going to be binary cross entropy, and metrics is going to be AUC. And the reason why the metrics is AUC is because that's the metric that Kaggle is using to score the to score the predictions. But I looked on sklearn, and I personally didn't see any metrics for AUC on sklearn, but it is available in TensorFlow. So now we set up with early stopping. So if the loss has not improved for 10 epochs, then it will just stop early. So that's good. And now we fit our model with a validation split of 20%. So it's X, Y, validation split of 20%, 100 epochs. A batch size is 256. Our verbose is 1. That means you can see what it's doing. Callbacks is early stopping. And class weight is class weighted. And then so now we're going to go through our 100 epochs. But it's not going to go through all 100 epochs, and the reason why is because it's set up for early stopping. And because it's set up for early stopping, it'll be like 35 or 36, something like that. It says epochs 37, early stopping. So now we're going to predict on the test set. Pred equals model.predict x test. And then you've got your pred, which is your predictions. Okay, so the difference between predict in TensorFlow, the predict is going to give you a probability, a value between 0 and 1 in TensorFlow. And then if you want to make it a 0 or a 1, you've got to put extra code in there to make it work, whether it's a 0 or a 1. But that's the difference between using TensorFlow and the sklearn model. Because on an sklearn model, when you put predict, it's going to give you either a 0 or a 1 output if it's logistic, if it's a binary classification. But when you are working with TensorFlow, it doesn't give you a 0 or a 1 output. It gives you a probability between 0 and 1. So now you have a probability between 0 and 1. And so the difference, again, like in an sklearn model, if you want to get the probability, then you're going to have to use predict proba. But in TensorFlow, you don't have to use predict proba. You just use predict. So we've got the values on predict. And then so what we do is we prepare our submission. Submission y equals pred. And then we take the submission and we convert it to a CSV file. Index equals false. And then we take the CSV file and we convert that to a data frame. And we read the data frame. And you can see that these are the values that are going to be submitted to Kaggle. And then when we submit the values to Kaggle, the best score that I got in that particular one was 96.257, which wasn't as high as what I got with gradient hist gradient boost classifier, but it was still high, and that's why I wanted to make this video, because it was still high even though it wasn't the highest, and I just wanted you to see another way to predict on a probability. So that concludes this video. If you like my video, please like and subscribe, and I will be making more videos for you very soon.